Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe.
So let's have difference formulas from negative relations. So we replace beta by negative beta. So sine alpha plus negative beta becomes sine of negative beta. So from expansion, sine alpha is cosine of negative beta plus cosine of alpha sine of negative beta. But cosine of negative beta is cosine of beta itself, while sine of negative beta is negative sine of beta. Therefore, sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine of beta. So sin cos minus cosine, it's the same. Sin cos plus cosine if that's plus. Then cosine of alpha minus beta is cosine of alpha, cosine of negative beta. Then plus sine of alpha sine of negative beta. So again, cosine of negative beta is just cosine beta, and sine negative beta is negative sine beta. So cosine of alpha minus beta is cosine alpha cosine beta minus sine alpha sine beta. Then tangent of alpha minus beta is tangent of alpha plus tangent of negative beta over 1 minus tangent of alpha tangent of negative beta. Tangent of negative beta is negative tangent beta, and tangent negative beta negative tangent of beta. So tangent of alpha minus beta is tangent alpha minus tangent beta over 1 minus 1 plus tangent of alpha tangent beta. The name for sum of two angles. When the sum of two angles is 90 degrees, then the sum is called complementary angles if the sum is 90 degrees. Supplementary angles if the sum is 180 degrees, supplementary angles. Explementary angles if the sum is 360 degrees. Then we have equal angles formed between two lines. So if we have an angle of inclination of theta, the angle between the normal and the vertical is also theta. So to prove, because this is the normal line, it is perpendicular to this given line here. So we can draw a vertical line through this intersection, and we have a right triangle here. So this is 90 degrees minus theta. So that means this angle here is theta, and that angle there is also theta. These two are equal. So this is 90 degrees minus theta, so that must be theta. So that is also theta. So that's why the angle of inclination is angle between the vertical and the normal to that inclination or inclined plane. Similarly, if we have this inclined angle which is downward, so if this is angle theta, again the angle between the vertical and the normal to this inclined plane is theta. So again, this is 90 degrees minus theta, so this is 90 degrees minus theta, so therefore that must be theta. And that angle is also equal to this angle. So angle of inclination is equal to the angle between the normal and the vertical. Angle of inclination or depression is equal to the angle between the vertical and the normal. Then we have tangential and normal components of a force or a vector. So we have here the x and the y axis, and let us say these are the tangential and normal axis rotated through an angle of theta tangential. So this is the force, and its components are Fx rightward, Fy upward. In this configuration also, it's not always, so just do not memorize the formulas because you can set up it depending on the inclination of the force F and the rotation of the tangential and the normal axis. So Fx and Fy. Then for the normal and tangential first. So we have Ft here, which is equal to that component, and F normal will be this, equal to this also. So that's the F normal. Then if the angle that F makes with the x-axis is theta, and the angle that the tangential axis makes with the x-axis is theta t, then the angle of this triangle here, which is right between Ft and F normal and F, the angle here, the measure of the angle there is theta minus theta t. So let's separate it here so that we can analyze it well. So this is F, this is theta minus theta t from, as I mentioned there. Then this is the tangential component Ft, and that's the normal component Fn. So from the figure, F tangential in terms of theta and theta t is F magnitude of F times cosine of quantity theta minus theta t. That's the tangential component in terms of theta and theta t. While the normal component, which is this opposite to theta minus theta t, is magnitude of F sine of quantity theta minus theta t. So another way is if we express it in terms of fx and fy. So from this figure here, so that's also theta t also. Then if we extend from this point, tip of fx and tail of fx, they meet 90 degrees here. So since this is fx and this is theta t here, this opposite is fx sine of theta t. This is fx sine theta t, while this is fx cosine of theta t. So fx sine theta t, because it is opposite of theta t and the hypotenuse is fx, opposite, the angle is theta t, so fx sine of theta t. This is adjacent of theta t and the hypotenuse is fx, so this is fx cosine of theta t. Likewise, if we extend from the tip of fy perpendicular to this, so this is, the hypotenuse is fy and the angle here is theta t, so this is fy sine of theta t, and this adjacent side is fy cosine of theta t. That's fy cosine theta t. So ft therefore is, it is equal to the x, the tangential component of fx is f cosine theta t, and it is in the direction of ft, so that's positive. While the tangential component of fy is in this direction opposite, so it is it is positive also from the normal axis. It is perpendicular to the normal axis, so it is going in that direction, just like the x component, the tangential component of fx is in that direction. The tangential component of fy is in the positive tangential direction, so both are positive. So ft is fx cosine theta t plus fy sine of theta t. So ft is fx cosine theta t plus fy sine theta t. But do not memorize this formula, as I said, because f may be directed in different direction and t may be directed also, the tangential and the normal components may be directed in different direction also. So what we have here is to set up this equation based on the components of fx and fy along the tangential, along the positive tangential direction. So that's it. So do not memorize. For the normal component of the force, then this component of Fy is in the positive normal direction, while this component of Fx is in the negative normal direction. So therefore, Fn is Fy cosine theta t minus Fx sine theta t. So f sub t is Fy cosine theta t minus Fx sine theta t. So that's it. Then to demonstrate, let's have this example. For example, F is 200 newtons, theta is 50 degrees, and theta t is 35 degrees. So it is the same as the location of F here, so we can use these formulas. So using this formula, but as I said, do not memorize, Ft is 200 cosine of 50 minus 35, 15. So it is the shortest is 200 cosine of 15. And it is also equal to fx. Fx is 200 cosine of 50. This is fx. Then times cosine of theta t, which is cosine 35, plus fy. Fy is 200 sine of theta, 200 sine of 50, then times sine of theta t, which is sine 35. So evaluate 200 cosine 15, or f cosine quantity theta minus theta t, and compared it with this formula here. The result is the same, 193.80 newtons. Likewise, f normal is 200 sine of 15. 50 minus 35 is 15. Then it is equal to 200 sine of 50 times cosine of 35. 200 sine of 50 times cosine 35, then minus 200 cosine of 50 times sine of 35. So that, compare 200 sine 15 with this value, which is longer, and the answer is the same, 51.76 newtons. So that's it for this example here. So next, let's have series of sample problems so that you can enhance the different trigonometric and geometric formulas that we have, which are necessary in statics. So problem 1, determine the angles alpha, beta, and gamma. So this is the figure. So this is 20 degrees, and we know that alpha is equal to 20 degrees. Then beta, because this is a right triangle, beta is 90 minus alpha, the complement of alpha. Then gamma is the supplement of beta, or gamma is 180 minus beta. So for the solution, alpha is 20 degrees also, beta is 90 minus 20, or 90 minus alpha, so beta is 70 degrees, and gamma is 180 degrees minus beta. So 180 minus 70, gamma is 110 degrees. Then for problem 2, determine the angle alpha. So the figure is here. So from the figure, take note that this is also 15 degrees. This angle is 90 minus 35, so this is 55 degrees. This is 15 degrees. And therefore, alpha, by experience, is 55 plus 15. So you can show that alpha is 55 plus 15, or 70 degrees, because this is 180 degrees minus 15 minus 55, so 110. So alpha is 180 minus 110, or 70 degrees. Or charge it to your experience, it is also 55 plus 15. So alpha is 70 degrees. 180 minus 110 is 70 degrees. And problem 3, find the length of y and r. So this is the given right triangle. So since this is a right triangle, for y we use tangent of 50, which is opposite y over adjacent 7. So tangent 50 degrees equals opposite y over 7. So y is 7 tangent 50. Using your calculator, 8.342 units. Then we use cosine so that we can use 50 and 7 again, not the y. So that's the technique. Do not use the other elements if they are just solved. They may be wrong, no? But only if you can use this original given data. So cosine 50 is adjacent 7 over r, hypotenuse. So r therefore is 7 divided by cosine 50. So 7 divided by cosine 50 in your calculator, 10.89 units. Problem 4, if cable AB is 9 meters long, determine the length of cable AC. So you can use right triangle application here, but for simplicity and for shortness of solution, let's just use law of cosines here, because we're required to find the length of cable AC. So this is 40 degrees, and cable AB is, the length of cable AB is given 9 meters. Then this is 6. The measure of this angle is 180 minus 40. So 140 degrees. Then by cosine law, length of AC square equals sum of squares of the other two sides minus twice the product of the other two sides times the cosine of the angle opposite to the unknown side or the first side. So L squared therefore is 9 squared plus 6 squared minus 2 times 9 times 6 cosine of 140. So solving for L using your calculator, it is 14.13 meters. So for problem 5, determine the height of the pole shown given the measured elements below. So this is the given figure. So we have a right triangle from the eye level of the observer, and this 28 degrees. So that's vertical, this horizontal, therefore that's 90 degrees. So first, let's solve for the horizontal distance from the base of the pole to the observer. So let's have this triangle here. And since this inclined slope is this sloping terrain is given 15 meters, then this is horizontal vertical. We can solve this horizontal distance by Pythagoras theorem. It is square root of 15 square minus the quantity 1.525 minus 0.42 quantity square. So x1 is square root of 15 square minus this distance, quantity 1.125 minus 0.42 square. So x sub 1 is equal to 14.959 meters. Having known x sub 1, then use this triangle. Tangent 20 degrees is opposite, which is h minus 0.42 divided by x1, 14.959. So h minus 0.42 divided by x1, 14.959. So to solve for h, use your calculator there, 14.959 times tangent of 28, then plus 0.42. So h is 8.374 meters. Then problem 6, neglecting the size of the pulley at C, determine how far weight D rises as theta increases from 50 degrees to 120 degrees. So this is the given figure. Then the height that or the distance that weight D rises will be the difference of the length BC from this position to this position somewhere here. So that's the change in length of BC or change in displacement of BC. That's also the height that distance weight D rises. So for the first triangle, the angle here is 50 degrees. So we have given adjacent sides and the included angle. So we use cosine law to solve for length BC. Length BC square equals 4 square plus 3 square minus 2 times 4 times 3 cosine of 50 degrees. So in this triangle here, because remember this is negligible size. So just treat this as vertical. So by cosine law, length of BC square equals 4 square plus 3 square minus 2 times 4 times 3 cosine of this angle, which is 50. So length of BC therefore is 3.094 meters. For the second position, 120 degrees angle. So this is the length of BC. It increases, so this weight will rise as a result. So this is by cosine law, that's 120 degrees. So length of B prime C square is equal to 4 square plus 3 square, because this is still 3, minus 2 times 4 times 3 cosine of 120 degrees. So solving for L B prime C, length B prime C is 6.083 meters. So the analysis, the distance weight D rises is the difference between 6.083 and 3.094. So distance of weight that weight D rises is denoted YD. So YD is 6.083 minus 3.094 meters. So I hope that you can imagine, because the change in length in BC is the length or the distance that weight D rises, because it is connected directly to that weight D there. So Y sub D is 2.989 meters. So problem 7. A roller and lever mechanism is in the position shown below. Find the horizontal distance between A and C. the radius of the ruler is 50 mm and length of lever AC is 250 mm, while distance AB is 81.25 mm. So this is the given figure. So distance length of lever AB is 250 mm, sorry, not AC. So first we can, because this is 30 degrees, this is also 30 degrees. So that's 30 degrees. So we can solve this distance, call that x sub 1, because this is 50 mm and that's a right triangle. So that's x sub 1, let's call this x sub 2. And therefore, if we call this is 81.25 mm given. So let's call that theta B, this angle here as theta C. Then call that L1 from A to this point here. This distance is equal to 250 mm minus L1. So from this triangle X, let's set up the required length. Horizontal distance AC is x1 plus x2. Then tangent of 30 degrees is 50 over x1. So x sub 1 is 50 divided by tangent 30. So 50 over tangent 30, that's x1, 50 square root of 3 mm. Next, sine of 30 degrees is 50 over L1. So 50 over L1, so L1 is 50 over sine of 30, so L1 is 100 mm. So therefore, this is 250 minus 100. So we can solve theta C by sine law, and we expect theta C to be obtuse angle. And remember that if we use sine law and using our calculator, it will give us an acute angle. So bear in mind that theta C should be obtuse. So we will not accept the answer from the calculator. It should be 180 minus the answer from the calculator. We anticipate that theta C is obtuse, more than 90 degrees. So by sine law, 81.25 or 250 minus 100 as to sine theta C equals 81.25 as to sine 30. So theta C therefore is inverse sine of 150 times sine 30 over 85.25. So theta C is 67.38 degrees. As I said, we will not accept this answer because it is obtuse. So theta C must be 180 minus 67.38 degrees. And that would be 112.62 degrees. So having found theta C, we can now solve x sub 2 by sine law again. X sub 2 as so sine 112.62. So theta B, by the way, is 180 minus 30 degrees minus theta C, which is 112.62. So theta B is 37.38 degrees. So by sine law, x sub 2 as to sine of 37.38 degrees equals 81.25 as to sine of 30. So x sub 2 is 98.65 mm. Finally, the horizontal distance between A and C is x sub 1, 50 square root of 3 plus x sub 2, 98.65. So LAC is, using your calculator there, 185.3 mm. Then for problem 8, the bottom of the 6-meter plank is placed 2.5 meters from point C. So determine the distance BC and the shortest distance from C to the pole or to the plank, from point C to the plank. So this is the given figure. The length of AB is 6 meters and this is 2.5 meters. So we can use law of sines to solve for this angle, theta B, which is expected acute, and theta A also acute. So by law of sines, 2.5 as to sine theta equals 6 as to sine of 105. So theta is inverse sine of quantity 2.5 sine 105 over 6. So theta is 23.733 degrees. So by the fact that the sum of the interior angles of a triangle is 180, so theta A is 180 degrees minus 105 degrees minus 23.733 degrees. So theta A is 51.267 degrees. Then by sine law again, to solve for distance BC, so distance BC as to sine theta A, which is 51.267 equals 6 as to sine 105. So distance BC is 6 times sine 51.267 divided by sine 105. So distance BC is 4.846 meters. Then for the perpendicular distance of, or the shortest distance from point C to the pole, to the plank, and it should be the shortest distance, so it must be the perpendicular distance. So one solution is using this right triangle. It is 2.5 sine of theta A. So 2.5 sine of theta A, 51.267. So distance C is 1.950 meters, 950 meters. Another solution is using this right triangle here. It is distance BC times sine of theta. So 4.846 times sine of 23.733 degrees. Distance C is also 1.950 meters. Another solution is using the distance from a point to a line. Let's imagine that A is the origin, or let us denote A as the origin. Then the slope is tangent of theta A, tangent of 51.267, 1.2467. That's the slope. The coordinates of the point C would be 2.5 gamma 0. So obviously, because this is the origin, 2.5 gamma 0. So that's x1, y1. And the equation of the line is, remember, coefficient of ax minus, it should be minus because this is plus, minus 1y equals 0. There's no y-intercept because this is the origin. So the equation of line AB is 1.2467x minus y minus 1y equals 0. So if you check, the slope is negative 1.2467 divided by negative 1, so 1.2467. So that's correct. Then apply the distance formula, ax1, absolute value of ax1 plus by1 plus c over square root of a square plus b square. So distance c is 1.2467 times x1 2.5 minus 1 times y1 0. There's no constant, y 0 also, over square root of 1.2467 square plus negative 1 square, that's still 1 square, positive 1 square. So distance C is 1.950 meters also. So let's proceed to problem 9. Block A slides to the right until AB is vertical. So determine the change in length of distance AC. So this is the figure. We have the slope of this AB here, which is 1.5 meters. So from the horizontal, 4, 3 vertical, then of course from right triangle proportion, 3, 4, 5, 5 the hypotenuse. So we extend from B horizontal and from A vertical line, and we will call this distance X and this distance as Y. So distance AC is simply the hypotenuse of this triangle here with horizontal x plus 1.2 and vertical y. So x is hypotenuse 1.5 times cosine of this angle here, which is 4 over 5. So that's the distance AC. X is 1.5 times cosine of this angle is 4 over 5. So it is 1.2 meters. Y is hypotenuse times sine of this angle. Sine of this angle is opposite 3 divided by 5. So 1.53 over 5 is 0.9. Y is 0.9. Therefore, distance AC by Pythagoras theorem is square root of quantity x 1.2 plus 1.2 square plus y square 0.9 square. So distance AC is 2.563 meters. So when A is moving or sliding to the right until this portion AB becomes vertical, so this should be the figure. And remember that the length of AB, which is also this length here, is 1.5. Because this y here is, this is 0.9 always, therefore this length is 1.5 minus y. 1.5 minus 0.9 is 0.6. So this is also 1.2 because this is CB or CB prime, and this is 0.9, so that's 0.6. So the horizontal distance or horizontal projection in BC prime therefore is x sub 1. And this is the distance A prime C. So the change in length of AC is distance AC minus distance A prime C. But before distance A prime C, let's solve for this horizontal distance, which is x1. And in this right triangle, we apply Pythagoras theorem. X1 is square root of 1.2 square minus 0.6 square. So x sub 1 is 1.039 meters. Having known x1, we can now compute distance A prime C by Pythagoras theorem again. Square root of 1.039 x1 square plus 0.9 square. So distance A prime C is equal to 1.375 meters. So the change in displacement or change in length of distance AC is 2.6563 minus 1.375. So the change in length of AC is 1.188 meters. Then this is our last problem for static 0. At noon, from a certain port, ship A leaves in the direction north 30 degrees east at the rate of 40 kilometers per hour. After 1 hour, another ship leaves the same port at the rate of 60 kilometers per hour due south. Determine the bearing of the first ship relative to the second ship and the distance between them at 2 p.m. So from 12 noon to 2 p.m., the first ship has traveled a total time of 2 hours, while the second ship has traveled only 1 hour because the second ship starts at 1 p.m. So this is the first ship and its direction north 30 degrees east. So this is 30 degrees. So this length or this distance traveled by the first ship is speed 40 kph times travel time 2 hours. So 80 kilometers. 40 kph times 2 hours is 80 kilometers. Then for the second ship due south, its distance traveled from the port is 60 kilometers per hour times only 1 hour because the travel time of the second ship is 1 hour only. So 60 times 1 is 60 kilometers. So we have here distance SF after 2 p.m. and let's call this angle beta. So to solve for distance SF, we first solve this component of distance traveled by the first ship, and this is horizontal, this is vertical, and the angle is 30 degrees, and the hypotenuse is already solved, 80 kilometers. Therefore, this XF here is 80 hypotenuse sine of 30. So that's the opposite. 80 sine 30 is 40 kilometers, while this component is hypotenuse adjacent, so cosine of 30. So that's 80 cosine 30, so 40 square root of 3. So XF again is 80 sine of 30, hypotenuse sine of 30. So let's call that distance SF. So XF is 80 sine 30, so it's 40 kilometers. Use your calculator there. Remember, sine 30 is 1/2, so 80 times 1/2 is 40 kilometers. Then YF is hypotenuse cosine of 30. So 80 cosine of 30 is 40 square root of 3 YF. Then this is 60. So one way of computing distance SF is square root of, by Pythagoras theorem, square root of 40 square plus quantity 40 square root of 3 plus 60 square. So distance SF is 135.33 kilometers. Another way of computing SF is to consider this triangle FPS, and the measure of the angle at P is 150. 180 minus 30 is 150. Then we use cosine law. So distance SF square is equal to 80 square plus 60 square minus 2 times 80 times 60 cosine of 150. This is 150 degrees, 180 minus 30. So using your calculator, distance SF is also 135.33 kilometers. And finally, for beta, again, using this right triangle here, tangent of beta is XF over YF plus 60. So 40 over 40 square root of 3 plus 60, using your calculator, beta is 17.19 degrees or 17 degrees 12 minutes. Another way of solving beta is using triangle FTS and by sine law. So 80 as to sine beta, beta is acute, so nothing to worry, equals distance SF as to sine 150 degrees at angle P. 80 as to sine of beta equals 135.30 as to sine of 150 degrees. So beta is inverse sine of 80, quantity 80 sine 150 over 135.33. So that's also 17.19 degrees or 17 degrees 12 minutes. So the bearing of the first ship relative to the second ship is north beta degrees east, north 17 degrees 12 minutes east. So that's it, and I hope that all these problems are helpful in your journey in studying statics, especially for beginners. And thank you for watching for this very long video.